Hello, everyone. I'm Jim Garrison, and I want to welcome you to day 146 of Humanity Rising. Humanity Rising is an initiative of Ubiquity University and over 350 partnering organizations that arose out of the midst of this pandemic when we were seeking with partners around the world to provide an open space so that people could come together and share their experiences and solutions and visions and confer as to how we can increase our strategic effectiveness. And each day we have, since May 22nd, brought to public profile a range of, well, now over 600, 700 speakers who've covered virtually every domain of human interest during this extraordinary moment in our history, where a small, almost invisible virus has stopped the world and put most of us in lockdown and generated a new form of social interaction, social distancing, not social intimacy, and a challenge to our healthcare systems that are ongoing 7 months after the beginning of the pandemic. Today, we want to delve into a particularly important realm. We are following up on our discussion just yesterday about David Bohm and Krishnamurti and the unity of everything, a dialogue that Peter Mary convened about the physicists and the spiritual master and their perceptions of the deep nature of reality. And today we want to go a bit deeper, and we want to delve into what it is that actually constitutes the unity of everything. What is it that unifies everything together, actually? So that's our subject at hand, which we'll get to in a moment. But first, we want to just take a minute and pause, take a few deep breaths, place your attention on your heart, maybe put your hand on your heart. And in a spirit of gratitude and thanksgiving that you're alive at this most extraordinary moment in history, just listen to your heartbeat. Thank you, everyone. Now, with an open heart, I want to introduce our speaker for today by way of the fountainhead of Western philosophy and science. The philosopher Pythagoras, who lived and taught in the 6th century BC, over 2,500 years ago in ancient Greece. We have a course each year at Ubiquity University, the Great Books course, and then the Great Lives course. I'll put the link in a moment, but in January and February, I'll be talking about the life of Pythagoras and his wife, Theanos. Pythagoras arguably is literally the fountainhead. Everything in Western philosophy and science follows from Pythagoras. Many people think of Plato or the pre-Socratics as the fountainhead, but for several hundred years after Plato, Plato was called a Pythagorean. And it was Pythagoras who was a contemporary of the Buddha. Think of the Buddha in India and Pythagoras in Greece, contemporaries, great minds, deep seers who instituted the major intellectual, philosophical, spiritual traditions of their respective hemispheres. Many things can be said about Pythagoras, but it was Pythagoras who really took the time to consider the true nature of reality. He was an extraordinary being. Very little is written about him that is contemporary. He was highly secretive, but what we do know from Tianos, who led his community after he died, and other contemporaries, that Pythagoras could sit in such deep stillness that he could literally hear the sound that the planets make in their orbit. Now just think about that for a moment. If you sit quietly, can you even hear the birds outside? Can you hear the sound that the Earth is making as it whirls through space? Can you hear the distinction in the tonality of the moon, of Mars? Pythagoras could. And within that capacity for deep stillness, he discerned that the emptiness of space is actually comprised of geometric shapes and mathematical equations. And that's why Pythagoras is considered, in many ways, the original scientist. He was the first one that we know of to say that all that is constructed in a combination of geometric shapes, most fundamentally, mathematical equations in terms of how it all fits together, and sound. That there's sounds associated with the configuration of space. That was forgotten over the centuries. But with the physics and the explorations into cosmology and cosmogenesis and neurophysics, quantum mechanics of the mid to the late, now early 21st century, mid to late 20th century, and now early 21st century, the notion that Pythagoras could see 2,500 years ago is now coming into scientific exploration in a way that is exciting and invigorating. And we are going to talk about it today. So it's in this spirit that I want to welcome Joseph Truss, who's a deep researcher of these matters and the author of the Book of Codes, which is really looking at the geometric configuration of space as it constitutes everything that is. So when you talk about the unity of everything, you have to understand the omnipresence and the ubiquitous nature of geometry at the heart of existence. So Joe, I turn the platform over to you, and I think everybody would appreciate it if you would start by maybe telling your story and how you got involved in this extraordinarily profound insight around the sacred geometric shape of existence.
Thank you, Jim. What a wonderful beginning to an exploration that continues after 500 years or so with the present that we know. Give me a second and let me see if I can get my share screen up without too much trouble. Let me ask Rick if that's working.
Yeah, it looks fine, Joseph.
That's okay?
Yeah, good.
So this most recent, I was born in Barbados. I was originally a musician. I moved to Canada as a young adult. I was involved in business and management. And then I met Stafford Beer in 1990. Stafford is the founding father of management cybernetics, which is the organization people aspect of cybernetics, which is the science that fed into artificial intelligence and robotics, and all of the whiz-bang stuff today really comes from the field of cybernetics. Today, probably the Santa Fe Institute in complexity theory are some of the leaders in this field that was opened up in that time. Now, Chris and I spent a lot of time with Stafford, but I'd like to start with this poem by Antonio Machado, which was one of Stafford's favorites. And forgive my scratchy voice, Stafford had this beautiful resonant bass voice and spoke perfect Spanish, neither of which I have, so I'll read it to you in English as it is here. Walker, your footprints are the path and nothing more. Walker, there is no path. The path is made as you walk. Stafford played prominently in the foundational formation of the work that has resulted in, which is a work in progress, the Book of Codes, that Chris, my life partner, and I have been working on these past 30 years, from 1990 when I started. This is 2005, and first of all, I would like at this point to say thank you, Jim, for that wonderful introduction again, and to welcome the participants and viewers, those who are live and those who will be visiting with the streaming service afterwards. As Jim said, my name is Joe. I don't go by Joseph. Joe is great. And I am half of a work and partnership, a life partnership with my wife, Chris. She's here, but not on screen. She's holding the cane to drag me off when I start to. But she deserves more than half of the credit for the work that has resulted in the Book of Codes. This photo was taken in 2005 at Quarrel Isaf, which was Stafford's cottage in Wales. And we have a partnership with the Malik organization, Fredman Malik. And when Stafford died, the cottage was refurbished, and that structure behind our heads is called an icosahedron. I'll talk a little bit about that as we go through it. Basis of a group methodology called syntegration that has now been done many thousand times around the world in every scale of organization, including governments themselves. So as introduction as well, I have to refer back to Jim, who is so passionate. I've watched quite a few of his introductions. His passion in mind, body, and beyond is so clearly articulated when he speaks about the critical state of our world, the systemic causes that underlie the reality that we experience, and the urgent need for shifts in mindsets and frames and metaphors and geometry. Yeah, geometry. After all, he is a Pythagorean, and he can see those connections as made by the quadrivium of Pythagoras that Jim talked about so much, which was the four liberal arts of Pythagoras, and they included number and geometry, music and cosmology. All of these aspects play very, very seriously in the work of Book of Codes. There we go. Now, a purpose, if not the purpose, of these 45 minutes together is to challenge you to provoke a shift in yourself. It might be just a little shift, a shift of perspective. It allows you to reframe the context. And when you reframe the context, you change your perception. It's your frame and your picture that we're talking about. We're challenged by this two-dimensional screen that sits between us, which can be very convincing that we're seeing 3D with all the wonderful graphics, but of course we are not. And you know, if a picture is worth 1,000 words, then an object is worth 1,000 pictures. So this slide shows my 3D notebook. This is a wall that I had, and this is how I kept my notes of structure in 3 dimensions on the wall. Typically in a session like this, we would have models built that were sitting. We would take breaks and help have the audience participate in building models. And also we would probably do some drumming to get the sense of the vibrations and the music happening as well. This is not a medium that allows us to do that today. Hopefully we will have an opportunity at some time in the future to actually have that aesthetic, the haptic experience of what's coming into your mind. So let's start from where we are. We have a common understanding in geometry all over the world today. It's called X, Y, Z. These are 3 axes of direction: up, down, right, left, or left, right, depending on how you're looking at me, and forward and backwards. Because these axes are at 90 degrees to each other, perpendicular, they form a cube, which is a polyhedron with 6 square. We'll talk a bit more about the terms polyhedron and so on. So the cube we all know, 6 square faces, sits flat. It's the most dominant artifact and object in our lives. We live in cubes. We do mathematics through a cubicle of the number system. We use them everywhere, ice cubes, etc. And we like them, you know, we just like cubes. So let's see. The thing about cubes is that it locks us into this thing called a matrix. We are locked in, believe it, we're locked in. We need to shift in order to get out of the frame of the matrix. So what is the matrix? The matrix is an XYZ 90-degree cubical frame or lattice or grid, which is the simplest possible scale if the cube is your simplest possible object, which we will show it actually is not. So this is the XYZ coordinate system. And one shift we want you to make with this diagram is to move away from the sense that you're standing in a cube and get into the actuality of how we are integrated in the cosmic energy and the cosmic flow and the cosmic grid, what we call the lattice, that fundamental grid along which everything goes. And that figure on the bottom right is a person standing with, in fact, a cube around them. But the cube is positioned, instead of lying flat, it's positioned as if it's standing on a point. But it's still a cube. The figure on the left of that, if I can point to that, is a tetrahedron. And in fact, the tetrahedron is actually the tiniest little star of our show, because the tetrahedron, as it happens, turns out to be a fundamental unit of nature, of geometry, of mathematics, of the world that we actually experience. So here it is, the star of the show, the tetrahedron. The tetrahedron is a triangular pyramid. We're very familiar with the pyramids that sit on a square base, the pyramids of Egypt, etc. And it has 4 triangular faces or sides. Tetra means 4, hedron means side or face. So tetrahedron, 4 triangular faces, tetrahedron. All of the polyhedrons, poly meaning many, hedron faces, go by that. So we say the tetrahedron. Instead of the hexahedron, we call that the cube. And then there's the octahedron, the icosahedron, dodecahedron, words you don't have to worry about. We'll have a chart, we'll show those. But these are the polyhedron, and don't get confused by these simple terms. Tetrahedron is this, the triangular, it's the smallest, and it is the informed structure. Information, IN hyphen formation, speaks to the fact that structure itself has an inbuilt informational basis that it can express in energy and matter, in solidity, in things, in density, in form. The tetrahedron is more than just the smallest polyhedron. It is the fundamental unit of nature. You could call it the atom of structure. From its molecules, the structure grows. The tetrahedron is the first object that can be considered 3-dimensional. If I have only 3 points, as the bottom of this thing shows, I have a triangle, which is the first and smallest enclosed space. You can't enclose space with just 2 lines. And if you put 3 lines together and you make those lines equal, that is the smallest conceivable space. Now, to get off of that space into our 3-dimensional world, we have to add a 4th point or distinction. So it takes 4 distinctions to make 3 dimensions. You cannot form a dimension with less than 2 distinctions. So already we begin to see something emerging out of the aspect of this tetrahedron. So this is a little exercise to kind of explain what that means. Let's start with a point. Now, a point has no substance. It actually doesn't exist. It's just a placeholder. You put a point, you say, well, the point doesn't matter, but it's a place. The point tells you where this place is. And in mathematics, that's considered to be 0 dimensions. You can't get a dimension with a single point. If I take 2 points and I draw a line between them, I now have a 1-dimensional plane, a 1-dimensional line, I'm sorry. It takes 3 points to make the 2-dimensional plane, the triangle, as we said. And then the 4th point lifts you off of the flat space from flatland into 3-dimensional space. So again, no dimension exists without at least 2 distinctions that allow you to understand that it's in fact a dimension. Here are the regular polygons. This is the group within which the tetrahedron is the smallest. Now, why is it called regular? The regularity comes from the fact that each one of these 5 objects, and Plato demonstrated that there are only 5 of these objects. You can sit and play with objects for the rest of your life. You will never find another configuration that matches this regularity, which means that every edge is of the same length. Once you establish a face, triangle or square or pentagon, that face is continued across the whole figure. And so if you count the number of connections at each vertex, you'll find that they're equal. That's what regularity means. And this is what the regular polyhedra are. And these are called the Platonic solids. Typically, this is where we would stop and build these models. We would have large models on stage that have templates of paper you could fold, jelly beans and toothpicks to make the physical structure of these models. Again, this is not the correct medium to do that, but as much as possible, we want to get you off of the 2D screen where you're imagining 3 dimensions and into 3-dimensional reality where you can actually construct and work with the way nature actually operates. I want to make one little point here about icosahedral geometry. The icosahedron is the basis of disintegration. It was the main connection between Buckminster Fuller and the famous geodesic dome and Stafford Beer. Bucky once said to Stafford, you know, all systems are polyhedral. Stafford thought about that for a long time. And he was looking for a system to work with groups. And he thought, well, let's start with the largest of the regular polyhedra. And so we came upon the icosahedron. Viruses, the very virus we're talking about today is in the shape of an icosahedron. Why? Because there are three aspects in nature that determines what things are. The size, its shape, and its stickiness. So let's look at this virus, this COVID-19 virus. It is under 4 microns small, so the mask that you're wearing have to be a filtration system for that. So that's number one advantage. Number two, its shape. It's an icosahedron. It is the most energy efficient, effective structure that is in nature. Holistic efficiency is called. Imagine that to a virus. Nothing is in vain in nature, as Aristotle said. Nature is economical, always seeks the least energy for the most efficient form. So here's our minimum structure, and this we walk to the structures that we model all have tangible, testable attributes that persist across physical scales. Why is this important? I am not a mathematician. In fact, Stafford was not a mathematician. We understand enough about maths as lay people and as working mathematicians, but by no means could I claim to be a mathematician. I am a geometer, however, which was an awareness I didn't have before. So these structures are actually nature's way of proving to mathematicians that these things exist. Now, I can do geometry and a mathematician can understand the structures I build. That's the advantage of these structures. Mathematicians understand you, and that means you can actually work in science and demonstrate proofs that they would then have to turn around mathematically and kind of operate. So, in terms of continually shifting our perspective, here we go. So without the simple regularity of the platonic solids, our universe would not be as it is. This regularity repeats, it reverberates, it resonates throughout the entire system of the universe. And from the fundamental atom of structure, all structure unfolds. Where does the information in the structure come from? Matter and energy are informed, formed, components of structure. The structure itself has the information it needs to realize itself. Now, right between the very smallest and the very largest in this various systems of universe that we're sitting in sits the sphere of humanity. We happen to be right dead center almost, the middle of the scale of universe. The scale in terms of size, the scale in terms of where life is, and the scale in terms of viability of structure. The problem faced by cosmology today is the incompatibility in our mathematics and physics when we move from the smallest, as Jim referred to, the quantum mechanical, the very tiny realm, up to the largest, the cosmological, the cosmic scale. When these two scales get together, they don't meet. They collide with this enormous discrepancy, something like 122 orders of magnitude of difference. These two theories, one that's the best tested theory in large scale cosmos, and the other is the best tested theory in the small scale. And so scientists today typically say, oh, just shut up and calculate. The equations work, and the fact that they're incompatible doesn't matter. But to philosophers, it does matter that there's this deep inconsistency. So, oh, sorry, I have a dog here and a wife. So this incongruency, this inconsistency, this incoherence, I believe is also shared by humanity today. We face a very similar chasm of internal inconsistency and incoherence. This little self in this infinite space of other. How do we shift ourselves, our mindsets, our perspectives, our fears? So there is this intersect of cosmology, quantum mechanics, and mathematics with this profound incompatibility that's paradoxical and problematic. But there's another intersect of cosmology, geometry, and the sacred or the mystic that reveals itself in physical structure. This has been essentially what I have been seeking for the last 30 years of my life. So, Dorothy, we're no longer in flatland. Here we are in real space. The body is a temple is a term that we've heard so many times before. And it usually is kind of a bit of a dig. Hey, you know, your body is a temple. Take care of it. You know, stop drinking, stop smoking, do all this stuff. I like to reverse that. I think the temple is the body. And the body embodies the cosmic code. It's all within, right? So to shift our perspective is a part of this going within and recognizing that as above, so below, but in fact, as below, so above. So back here, actually, the example of as below, so above is that every individual cell in your body, a cell is a very, very tiny thing. Every one of those individual cells in your body does everything that the whole body does. It takes in food, it exchanges energy, it excretes, it has perception, it responds to its environment. All of that comes from this awareness. And there are 100 trillion cells in your body, and each cell has 100 trillion of these smallest little atomic structures. So we're talking about a very, very vast scale that is typically very difficult to get your arms around, get your mind around. Now I'd like to do a little bit of a thought experiment for those of you. Get up, move your body a bit maybe, but here's a little physical exercise, very simple. And of course, if you're unable to do it, just close your eyes and do it as a thought exercise. I'm just asking you to stand up. I'm standing. Take a minute, just close your eyes, just feel what it's like to be standing. And then sit back down, close your eyes, feel what it's like to be sitting. Now feel yourself pressing on the chair that you're sitting on. You're being pulled into the ground by gravity, no? Or are you being pushed onto the ground? You see, you couldn't tell the difference. Einstein found that acceleration and gravity are the same thing. They're equivalent. So whether or not I'm being pushed on the ground or I'm being pulled to the ground, to me feels the same, but to mathematics and physics means a very big difference. This extraordinary little ratio is the ratio of, if I take the cube and set it on point to point, and then I make it flat, the difference between those distances is 7 to 5. If I stand and mark myself, and then I sit, the ratio of that is 7 to 5. So I kind of say I am a tetrahedron, and that's how we walk. I'd like you to do one other little exercise. We'll go back to this one. Imagine that you have a cube around your body, so it's resting in the ground the way the cube does. And I want you to try to imagine what it would be like to walk. You'd be shuffling by dragging your feet left or right. You would not be walking. Now, I want you to imagine that there's a tetrahedron hanging around your neck. A cube is two tetrahedrons that are intersected. We'll show you how that happens. But here's the tetrahedron. And if you imagine that tetrahedron around you and you're standing, walking is the most natural thing in the world, because walking is actually falling and putting one foot in front of the other to stop yourself from falling. When we're standing in gravity, we are constantly rebalancing. All the micro movements, everything that's happening in the body is because of that. When you're sitting at rest, time moves the fastest. Life wants lots of time. Life is about movement. And so we say gravity is your friend. Movement is what you need to be doing. Sedentary behavior today, sitting, is as dangerous to your health as smoking cigarettes was. Yeah. I'd like to take a minute now. This is where we would basically stop, take a deep breath, read a poem. I'm a drummer. We would play some drums and have some participation. But instead, I'd like to invite Jim to see if there's anything that we might need to clarify, any questions in the chat that he thinks would be relevant at this point before I carry on to the second part of the presentation. Jim?
Well, no, Joe, you're on a roll. I would just sort of keep going, and then we'll circle back after you finish.
Okay, wonderful. Let me see if I can get my screen back. Where are we? Is my screen back for you?
No, not yet, Joe. You click on the program. Remember when you go to the share?
Oh. I'm trying to get my screen back and I can't. Sorry.
So go to the share and then click
Stop
on
share.
the.
Let me reshare and see if I can get that back.
There you go. You got it.
That's it.
Yep.
There
Thank
you go.
you. That wasn't too bad. So we were talking about embodying the cosmic code, exercises in spatial intelligence, which invites whole body learning. We want to provoke learning here. This is not about truth even, or it's about what makes sense to you. Meaning structures, the metaphors that you use to make meanings in the world, the structural metaphors, I believe, are the deepest metaphors in our lives. We live by them. We could meet totally different people, different languages, different ethnicities, and so on. And we all kind of understand up and down, whatever terms we use for it, right and left, forwards and backwards. Structure of metaphor, a structural metaphor exists within us at the deepest level. And I believe that is so because our brains have had to deal with these structures in order to evolve, to survive. We are inherently master geometers, every single person with a brain, because your brain has survived by being able to operate in the environment. And if it didn't, you died. You survived because you were able to determine if the object coming to you was far away and big or close to you and small. That made the difference between living and dying. Was that a snake on the ground or today a garden hose? Well, you'll jump when you see a garden hose because that part of the limbic brain, that part of the deep reptilian brain in your body, the amygdala, connected to the amygdala, is driven by fear. And fear, in fact, is one of the issues that we are most challenged with today. Oh, there we go. So this way of thinking is more than just about modeling the physical world with these structures. It really is about relationships among entities, a bridge of bridges. You know, sometimes a picture is worth 1,000 words, but I would love to be able to build a bridge of bridges as a huge art installation. The world is coded in structure, not in pictures. So very briefly, this is what the Book of Codes is about. It's about the connectivity of what seemingly disparate subjects are about. We've dealt with cosmology, structure and information, geometry and mathematics, biology and life, culture and arts. Philosophy, science and technology, and system science is all a part of what this internal structure, which is an architected, navigable structure, is about. So let's look at a little bit of geometry in the physical world. Most of us know what the Fibonacci spiral is. It really has to do with something called the golden rectangle, which appears in architecture all over the world, in art all over the world. And what it does reflect for me is the fractal resonance at all scales. These Fibonacci sequences in mathematics are found throughout nature at pretty much all scales of structure. Now, another example of the physical geometry. We've been talking about the cube here, but the cube is actually made out of intersecting tetrahedra. Here's the blue tetra and here's the green. And what you would notice for the first time is that this object in the center here with the yellow nodes and draw is an octahedron. And we will kind of, again, we went through, I think, the regular polyhedra very quickly, but the octahedron is octa, 8 faces, and it's one of the regular polyhedrons. So we see that in this cube itself, there are intersecting tetrahedra and an octahedron naturally existing in what would appear to be an empty cube. I have a story here that is about structure and information and how this information takes place. If we look at the
Joe, excuse me.
first, I'm sorry, yes.
You're making some kind of noise as you're talking. Sounds like papers are being shuffled or something.
Yes,
Maybe you could-
that is happening. I'm sorry. I think it's too close to the mic. Thank you. I'll take care of that.
Yeah, thanks.
Sorry about that. So in structures, especially the polyhedral, we use what's called a unit length. Once you've established a unit length, that is the same length that you use everywhere else. So this is the basic tetrahedron. It has 6 of these unit edges, 4 faces, and it's empty inside. So the center of this is the center of a sphere, a circle, that would fit right around the tetrahedron. To double the size of a tetrahedron, and that's how nature works, that's how music works, octaves are doublings. When I double that here, it means I've doubled the length edge of the tetrahedron. I end up with a larger tetrahedron. It's still exactly the same shape, but it's made out of 1, 2, 3, 4 tetrahedrons stacked. And here is that octahedron that appears in the middle of this structure. From nowhere, the tetrahedron is a fundamental form, and yet inside itself, as soon as it starts to grow, the octahedron appears inside it. If I added another length, I'd make a 3-frequency tetrahedron like this. The internal structure again changes, and what I have in the middle of this is an upside down tetrahedron. It's like the human organism. For the first time, the structure is able to see an image of itself in the way that we see with an upside down image. So we see the growth of identity from single seed, let's say, to a double that's expanding, to a triple that suddenly sees itself inside of itself, can reflect, and then finally we come to the 4-frequency tetrahedron. And inside this shape is a new shape that's called a cube octahedron, which we will introduce you to. But in this 4-frequency tetrahedron can be found all of the elements that you need to build the universe. I want to just make this quick little correlation between metaphors as a way of describing and structure as a way of describing. I came across this in Peter Mary's evolution theory, where he's talking about how a seed expands and it builds up until it gets enough energy. Up here, I think I'm blocking my own screen, to integrate and encapsulate all elements. And it immediately occurred to me that the story I just told you fits almost exactly. Energy is built up within the boundary of the seed, and we have the tetrahedron, the smallest seed that's contained. Energy breaks through the boundary of the seed to expand. It's the first doubling, the octave, that creates an equal space inside. This space inside is exactly equal to the space around it, 4 tetrahedral volumes. Energy continues to expand from the initial push and starts to see and reflect upon itself. For the first time in the 3-frequency, the tetrahedron has an image of itself upside down, like our optical system. And then finally, in the 4th, energy slows, it integrates and it encapsulates all elements. And in the cube octahedron, in the form of this, all of the previous forms have been integrated and encapsulated. And from here on, 4 is how the universe grows out of that basic structure. This is a model we use in a workshop. It's called Embodying the Cosmic Code. Many of you are familiar with something called the chakras. The chakras are usually shown as 7. There are 7 of these things, but there are actually only 6 chakras at this level. The 7th chakra is 72 octaves of the initial chakra. So we don't show it as in the same frame. This is a structure that we built. This is the smallest construction that's integral to by itself that represents the geometry of the chakras in terms of vibration and structure. As this structure grows from tetrahedron to cube, to octahedron, to cube octahedron, to icosahedron, to dodecahedron, it shows how the energy is actually flowing within a chakra column. We do meditations on this on the basis of the color and the structures. And of course, this messy diagram on the left is the human within which the chakras are existing. So what do we have here? Well, what is all of this about? What is it for? You know, all of science depends on having an atomic theory and a model of the atom, the smallest brick in the wall. Richard Feynman, a very famous physicist and cosmologist, said that if all of science was destroyed from future civilizations, there's one thing that he would like to be held. The most important thing is the atomic theory, because there is no science without an atomic theory. The quantum mechanical description of the atomic realm is mathematically the most precise description possible. But let's actually have a look at what precision means. Mathematics is the most precise language we have, but compared to any actual object, it is merely accurate to a defined level of precision, so many decimal points. The object itself, however, is physically as precise as it is possible to be, down to the atomic particles that make up these subatomic particles that make up the atoms of that thing. Structure is nature's way of being precise. Mathematics is science's most precise way of describing that structure. And the code is our way of understanding through structure the deeper metaphors that we live by. So, sorry, 10 minutes left? Okay. So what we have here is, we want to talk about is this XYZ and how it ties into mathematics. In mathematics, we have something called the real number line, which is just a stream of numbers from 1. The numbers are all related. Once you establish that 1, 2 is just twice 1, 3 is 3 times 1, etc. And they are put across a line where the distances are equal. 2 regularities. The unit is the 1 standard unit. Everything comes from that unit. And the distances between those units is 1 standard distance. If you change either of those 2 things, you can't have mathematics. And in fact, if you change any of those 2 things, you don't really have the world. So the problem of XYZ is the one that actually threatened Pythagoras. You see, Pythagoras thought that all of the whole numbers, all of nature worked on whole numbers. But when he actually invented the Pythagorean right-angled triangle theorem, one of his students showed him that if you have a cube and the side of the cube is 1, this diagonal is an irrational number, 1.41428, whatever. This actually is the closest decimal, the closest fractional approximation to what it is. The number is quite different, but this number goes on forever. And so this was so disconcerting to Pythagoras that they threatened actually to kill anyone if they revealed this secret. And it was the bane of the Pythagorean aspect. When it comes to whole numbers, this does not in any way deny Pythagoras. This is called the cube octahedron, the vector equilibrium. And without saying too much about it, we want to show you the shape. You saw this in the 4 frequency tetrahedron. In it, you can see that there's a cube, the squares, and there's a tetrahedron or an octahedron, which is the triangles. It indicates that this comes from the same family, and it actually is the source of the fundamental tetrahedron that we've been showing you. And one example of that is this figure on the left is an engineering structure that was built. It's called an origami frame. And they built this frame in order to capture a single gold atom in the middle of it. Now, at this stage, what I would like to do, no, I think I'll leave that. The cube octahedron folds down into this form. And this is the first time I've ever seen in engineering a form that represents what I have claimed is the real tetrahedron, real space. Very, very little bit about cosmology. The universe is in dynamic expansion, a balance between expansion and contraction. Dark energy and dark matter today make up 95% of everything that we don't know. Everything that we do know, all the physics and chemistry and everything, is 5% about of what we actually can count and see. So expansion and gravity. You know, a good analogy for this is between the tension and compression that exists in the icosahedron, which is the basis of the famous geodesic dome of Buckminster Fuller and the disintegration of Stafford Beer. Every force has an equal and opposite force, and the universe is in vector equilibrium. Gravity may be nothing more than the natural response of an expanding universe that naturally has like centrifugal and centripetal force. So space-time and space-time, these are one-liners to me that make a lot of sense. They're actually quite accurate. Space is nature's way of stopping time from happening all at once. And time is nature's way of stopping space from infinite collapse. You see, space and time are actually the same thing. When you move in a distance, you're affecting time. And when you move in time, you're affecting distance. Space and time get mixed by motion, and the flow of time depends on how you are moving. And space-time is the universal structure in which particles move. Everything in universe is vibration. The best metaphor today that cosmologists can find for the Big Bang, the very beginning of our universe, is the striking of a bell. A tremendously large bell, no doubt. But that's it, because it's the vibration, that simple vibration. And what we have found is that on the electromagnetic spectrum, which is the spectrum that covers everything from radio, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays, this range of energy across the universe is 72 octaves. That's 72 doubling of the single octave. This is a very, very, very big number. There's a story about the emperor who offered his provider that if he would do something, he would return the favor. The provider said, well, emperor, what you can do is you have a checkerboard. Every day you put 1 grain of rice on one of those checkerboard points, and every day you just double it. So the emperor looked at that and thought, hey, that looks pretty good. And he agreed. Well, of course, for him to have done that would have required more grains of rice than there are grains of sand on the entire planet. This is the number of 64 doublings. At the 65th doubling, this is doubled. So you can imagine the enormous scale of the universe is 72 octaves. And what I have discovered is that when I run these waves along a standard distance and unit number, the prime numbers appear automatically. I'll have to show that to you, but essentially this is a brand new way of predicting the primes. So what is the difference? The difference, it's information. And information is informed structure. Structure is informed energy and matter. It must abide by all of nature's laws. It is precision itself, which is why we build. I can make an apple float on a computer screen. I can't make an apple float in real space. We do all of our work in real space because everything comes back down to our dimensional space. Differences and similarities is what informs structure. There's no information if everything was the same. It is the difference and the similarities that informs the structure. And our world is built on broken symmetries. From the energies we feel today, to the art that we appreciate, to how beautiful a body looks. The difference that makes the difference is these broken symmetries. Perfect symmetry does not exist. That was what Plato talked about in terms of the ideal shapes. So what else have we learned? That starting from first principles of structure, we can comprehend the deepest, most interesting questions of life. That we can understand what science is about in terms that are meaningful to us without a lifetime of study of mathematics. And today, to be just a good, decent human in a modern economy like ours, you have to understand science. You have to understand something, otherwise you are in the bubble of ignorance. That we live in a frame of multiple dimensions, as many as 11 or 26, depending on what theory you follow, but they always exhibit themselves in 3 spatial and 1 time dimension, our 4-dimensional space-time. The Large Hadron Collider is blowing up these objects in incredible energies. Why? Because that's how we measure things. Empiricism means we see it. So it doesn't matter if there are 92 dimensions, it's what happens in our dimension that really matters. And finally, that a shift in mind, body, and spirit is emerging in global consciousness, and that we embody the temple. The temple is a body. I will stop there, Jim. Thank you. This is just an outline of the geometry, but at this point, I think I want to get back to seeing your face. There we go. Jim, are you back? I'm sorry. I seem to have lost someone or something.
Yeah, I'm pinging him, Joe.
So, I'm sorry. Did I interrupt you, right?
No, I'm just trying to ping Jim. He might go back to that last diagram and explain that a little bit. It was very interesting.
Certainly. Let's see, let's see if I can get my screen.
Oh, there he is. He's here. He woke up.
Good. Thank you. Sorry, Jim, I interrupted you by closing off a minute too soon.
No, that's quite all right. I was tracking it through other means. And what I'd like to do is start, Joe, by maybe going back to those slides on the relationship between space and time. That's very intriguing what you're saying about the way that space modifies time and time modifies space. And I think it'd be worth taking a few minutes to just go more deeply into that aspect. Yeah. So why don't you just enhance the optics on this one?
Sorry, can you see this?
Yeah.
Yeah, we're good, Joe.
Yeah, you're good. Okay. So one of the things that we began to recognize with Einstein's theory of relativity before the general theory is that time is relative. So it means that if I'm moving in one direction and you're moving in another direction, we typically pass each other by doubling the speed. If I'm driving at 10 miles per hour and you pass me at 10 miles per hour, at the point where we pass, our speeds relative to each other is 20 miles per hour. That's not the same with light. It doesn't matter where we are, how fast we're moving, light always appears to be moving at the same speed. And the only way that Einstein figured that could happen is because space and time are actually the same thing. When you modify time, you're modifying space. And when you modify space, you're modifying time. So as an example, if we go back, maybe this is a bit much, but that Big Bang beat in the very center, which is a wave that, omnidirectionally, we're on one part of that wave, the front of the place here, where the wave has expanded and we are somewhere in here watching it. But this wave has gone backwards equally, because when this happened, it was omnidirectional. We're tracking one cone of light in this direction, but in fact, it's omnidirectional. So if we look at that first beat of time, in order for a distance of one, let's say, aspect of time, let's call it a second just for convenience. When that 1 second happens, what it has happened is that a sphere has been created around it. It's omnidirectional, that one wave. And that sphere is always related to this one beat. So if this is the time of the second, space is the sphere. And that's the relationship between space and time. Every beat of that tick of time as the universe was expanding was creating a sphere equivalent to the radius of that to the volume of the sphere. So what happens is that if Jim and I are walking towards each other, as we're walking towards each other, the time is different than if I was standing still and Jim was walking towards me. Now that doesn't make any sense at all, other than the fact that as in fact we walk towards each other, both time and distance are related. So if space did not occur, there was no space, everything would happen at once. Time would be infinitely and spontaneously simultaneous, which means there would be no time. And the opposite is that, in fact, if time stopped happening, if time happening stops space from collapsing, it is that actual beat of time of that Big Bang vibration that actually causes space to expand. So here are two astronauts towards each other, And so what happens is they're actually mixing their space and time relative to each other. To an observer watching A, I see one thing. To an observer watching B, I see something else. And so the flow of time depends on how you're moving. The classic paradox is the twin paradox, where one person gets on a rocket ship, flies off the Earth at 90% the speed of light, goes away for 10 years, comes back, and the Earth is 400 years or 1,000 years older. Because as that person is physically moving at the speed, his time is running slower. The physical clock that he has in his rocket ship is actually moving slower because there's less gravity. The closer you come to gravity, again, the more attractive that is, the slower time gets. Which is why cosmologists like Leonard Susskind say, gravity is life. Life seeks gravity. Without gravity, there is no life. We usually say water is the basis of life. Without gravity, there is no water. So space-time and gravity are all intimately interlocked, but it is this distance and time aspect of space and time that for many people is very, very confusing. I probably have just confused you more. Sorry.
Well, no. Let's. Melanie just asked an interesting question, Joe. Is there a place where time and space do not exist?
The only place I can imagine would be a black hole. The density of the black hole stops. Again, this is totally speculative. I think that in a black hole, space and time are so densely intertwined that if anything stops, it would be there.
Yeah, and then Jody Weiss was asking another question around the Kashmir-Shavite concept of consciousness before it moves. It's called spanda, or motionless motion.
Yeah.
Do you have any comment on that?
It's a paradoxical oxymoron. There is no such thing as motionlessness in the universe. That's an abstraction of mind. Everything in the universe vibrates. The DNA in your body vibrates. The entire cosmos, which is why the electromagnetic spectrum is the code of the universe. Everything that exists in the universe you can find on that spectrum. You don't need to know about the strong force of the nuclear atom and the weak force of if you understand what's happening on the electromagnetic spectrum, and that this little piece is the part that we see as optical light, you recognize that everything in the universe moves. Motionlessness has to do with, to me, with the meditational concept of stillness. And stillness is a frame of mind. There is no stillness in the universe as far as I can find. Maybe at the center of a black hole, I don't know.
Right. Well, it's an interesting paradox to have motionless motion. I mean, it's similar to the Buddhist notion of emptiness is form and form is emptiness. You know, nirvana is samsara, and samsara is nirvana.
The Tao is not the Tao. There could not ever be one without other. So one, again, is a placeholder for an emergence of something that comes.
Right, yeah. Right. You know, another aspect of all this I'd like to touch on is Nassim Haramehn's assertion in his latest teachings that he says it's not so much space and time as space and memory that really binds together as one.
Not space and time, but space. Sorry, Jim, I missed that. Not space and time, but space and
memory. You know, and if you think of the Tibetan Buddhist notion about consciousness, they say that what constitutes consciousness is awareness and memory. And I'm just wondering, you know, where does memory fit into your understanding of space and time?
In a similar way that consciousness is a field, Consciousness is not owned by intelligent beings with brains, I believe. Consciousness is a field that permeates all of the universe. So I can look at a rock that's been in existence for 1 billion years. That rock has been exchanging information with the universe, exchanging atoms and molecules of itself. That, in fact, it's been changing its memory. If memory is a physical thing, that's what memory means to me. If memory is only attributed to brains and to intelligence, then we're talking about neuronal activity and the laying down of myelin and repetition. You know, the neurons that what's the expression? Yeah, neurons that fire together, wire together.
Mm-hmm.
So memory is an expression of what's happening in our brains, and memory as an expression of the limbic system, of emotion, and things of that is one aspect of memory. Just like consciousness, to me, human consciousness is one aspect of consciousness. Everything has memory if it exchanges something with the environment.
Yeah, and I think that's essentially what Nassim Harriman has in mind, you know, because what he's saying that at its core, the universe is constructed of these Planck entities that are vibrating in and out of manifest into the invisible to the manifest into the invisible, 10 to the 43rd times a second, which is just so fast, it's incomprehensible. But that this phenomenon of the vibration, the whirling, as it were, the spiral that you're talking about, is going from kind of manifest reality, like me and you on this Zoom call, into invisibility, into non-manifest, every 10 to the 43rd nano pieces of a second. And that what keeps the universe whole and learning is that these Planck entities, and therefore the cosmic fabric itself, remembers when it comes out of the invisible back into the visible. And then when it goes from the visible back into the invisible, the connectivity is memory.
Yes.
So I think that's what Nassim is getting at. And it's a very intriguing notion, because we know that memory is completely malleable. It's quite extraordinary. If memory is the connectivity, then as Nassim points out, we can actually reshape memories about the past and literally reshape the past and liberate ourselves into the future through the morphic shape-shifting of memory. So anyway, I just thought I'd bring that in and see what your comment.
That's wonderful, and I'm a huge fan of Nassim's work. I've been checking on his work as I have been developing my own, and we have arrived at identical geometries. Him from deep mathematics and physics, and us from first principles of structure, and we've arrived at exactly the same form. Can I show you one model quickly?
Sure.
Yeah. See, I built this.
Wow.
Now, this had nothing to do with Nassim. This is, in fact, an articulation of that 4-frequency tetrahedron that I showed expanding. And when I intersect those, I get this. Now, he calls this 64 tetrahedron. This is his model. Well, this model, remember, inside the 4-frequency tetrahedron was the cube octahedron. Now, this cube octahedron is called a vector flexor because it flexes. And this is the breadth of the universe. I have a mechanical structure to show how this is done. The connection is the Enneagram. The Enneagram is deeply embedded in the icosahedron. So if I do this and I compress it, this is an octahedron, one of the polyhedrons we talked about. And if I continue all the way down, let's take a little bit of skill. This is the tetrahedron I was showing you with 4 edges.
Oh, yes.
So like David Bohm's wholeness and the explicate unfolding from the implicate and refolding into the wholeness. The explanation of universe is this. This is what Nassim would call the Planck object,
Yes.
an empty cuboctahedron. As soon as it's exposed to gravity, it does this, and it creates the fundamental form of the tetrahedron. This is a tetrahedron, not the one that we showed, the abstract with single edges. This is a real tetrahedron. This unfolds and enfolds, and always, in fact, all of the explicate structures come from this implicate order.
Yeah, yeah. Well, that's so fascinating. And of course, Nassim also makes the point that you make, that the strong force, the weak force, electromagnetic, and gravity aren't different. They're just different ways that the vibrations of the Plancks and the cosmic, Akashic field vibrate and are measured. So that, that's another an extraordinary thing, is that it's all happening. And depending on how we're trying to measure it, we'll see gravity, or we'll see the strong or weak force, but they're not distinct forces. That's just the universe doing its thing. It's just like in our bodies, it's one body, in our endocrine system, and our immune system, and our cardio and our neural system. They're all one thing. It just, we tend to want to categorize something that is uncategorizable.
Indeed, yes.
And Kate Haber has a question, Joe. How might you explain those no-time moments when we are simply in the flow? What happens to time when you're in the flow? Does it stop?
Yeah, hang on. Yeah. Sorry, I just have to get another moment. This is a cube. It's made out of 8 small cubes, so it's a 2-frequency cube. Actually, it's a 4. These are 8 empty cubes. These cubes are all empty. There's nothing in the space of these cubes. And yet, all of the regular polyhedra, the tetrahedron, the golden rectangle are all existent in here. This structure is informed in itself, right? Now, in the very, very center of this structure, there's a tiny little light, a tiny little cube that's captured. And it doesn't matter what you do, you cannot get rid of that cube. That is what people call 0-point energy. So in this, I call that a space-time moment. That is the smallest representation of 1 beat of time. And that 1 beat of time, in the model, time would be from the center of this to one node, which is the sphere. Space is the entire sphere. That's why pi, 3.14, is ubiquitous all through nature, in statistics and in cosmic geometry. Pi is there because time itself, the 1 beat of time, which is linear, is connected to the sphere that surrounds it. And pi is what defines that sphere. Yeah.
Amazing.
So the point in the center of this, to me, is a point of either or both infinite energy and nothingness. I guess it depends where your metaphysics takes you in that realm. But there is a geometrical explanation in something called the Borromean rings, which are rings that are never connected this way, but they're interconnected. And once they're interconnected like that, they are inseparable. And if you were to compress the Borromean rings down to nothing, in the center of that is a tiny little cube that you cannot get rid of. So it doesn't matter how much you compress space down, there's this little piece that you cannot get rid of. And I believe that that's the piece that people are seeking for 0-point energy. It sits in the middle of a space-time moment. It is, in fact, the center of 1 beat of space-time.
Extraordinary. And then in and through all this, you're saying that, and this is Larry Cashin's question, that there's nothing possible without gravity. Gravity is sort of the essential condition for manifestation.
Again, gravity in the terms that we've been stating, which is gravity is the word we use to measure something. Attraction, I think, would probably be a better metaphor. The universe depends on attraction. Gravity is that. Gravity is attraction that is countervailing the expansiveness and the expansion of the universe. So the word gravity, yes, there is no life without gravity, because without gravity, the universe would have just expanded. There would have been no form, there would have been no structure, there would have been no planets, no life. And the fact that this attraction happened at the earliest stage of the universe that began this pull back into center. That's what gravity is. Gravity is a return to center of the expanding universe.
You know, it's amazing, again, to refer to Nassim and Plato. He says you can think of gravity as love.
Yes.
Gravity is that which binds it all together. It's the force of attraction that binds it all together as a singularity. And, you know, I love the symposium of Plato, just to do a discourse and then have your comment, you know, his notion that Socrates learned from the old wise woman Diotima about the nature of love. She said, love is a mediating intelligence.
Mm-hmm.
And it is that which binds everything together as a mediatrix and shapes it into something beautiful. So that love and beauty are an integral aspect. And the reason why Pythagoras coined the term cosmos means ornament, as you know, because he said, when you look at the universe, if you look at all that is, it's an extraordinary edifice of beauty. You know, he says the universe is as a cosmic sound, a cosmic poem. So I love this notion of gravity being like love. It's that which attracts and binds everything together as one. How do you?
Yes, and the other word that's exactly at that intersect is entanglement. And in fact, in the leading edge of cosmology today, many people are associating entanglement with gravity. You see, the closer bodies are, the more entangled they are, which is a description of gravity almost. So yeah. as Nassim has elucidated the holographic principle and made the distinction that this is not a two-dimensional frame. There are no two-dimensional frames in our universe, right? It may be thin, it's on a surface like a membrane, but it's not two-dimensional, right? What he brought to the holographic picture, I found very, very profound. But the other aspect of gravity that appeals to me is this conception of entanglement and gravity actually being the same thing. Because as we get closer to each other, we become more and more entangled at the subatomic level, true quantum entanglement. And what Nassim has shown is how the instantaneous communication across the entire scale of the universe, and then wormholes in the center of every proton. It's just that 10 to the 40. I mean, it's just an incredible, image that I can hold in my mind. So entanglement, gravity, love, life, I embrace them all.
Well, you know, we fall in love. It's so amazing. You know, this phenomenon of falling in love. You walk into a room and some people repel you. And then for a mysterious reason, beyond understanding, you feel this powerful attraction to someone. Yeah. And it's happening at an invisible, almost subatomic level, but you feel yourself literally falling in love. And you're getting into the gravitational entanglement when love casts its spell.
Gravitational entanglement in love, yes.
Now let me we're closing in on the on the hour, but let me ask you about the torus. What is it about the torus that seems in Nassim's work and your work in the Platonic, solids? What is it about the torus that is so fundamental?
In terms of number theory, looking at it just in terms of number, the four color problem is a problem where you say, if you have a map of the world, all you need are four colors to map all the countries, and no two boundaries will be the same color. Now that has been known for hundreds of years, but the proof has only been written maybe 20 years ago, and it's a topological proof. That was one of my first experiments, is I proved that using a tetrahedron in a very simple proof that you can actually see. But so fourness is a description of this boundary condition on the surface of a sphere. If you apply the same rule to a torus, a donut, it takes 7 colors. So that no two boundaries would touch each other.
Well, that's the rainbow.
This movement from 4 to 7, to me, is very, very significant.
Yes.
The unfolding of the tetrahedron is the complete balance between 3 and 4. It's like rhythm to us. 3/4 is waltz, 4/4 is our dominant rhythmic pace. Those two rhythms, 3 and 4 and 4 and 4, are nature's dominant rhythmic pattern. And 7 is this magical part on the number line that brings you into this infinity. And if I divide any number by 7, I get 1, 4, 2, 8, 5, 7 to infinity, which is the pattern of the Enneagram, the 6-pointed star, which is why the Enneagram was first seen as the perpetual motion machine. Once you get onto that circuit, you're on it forever. And 7 is the number that does that. 7 is also the famous number where if you get past 7 in a group of people, the groups tend to break off. You can't maintain one single group if you pass 7, right? So the number 7 keeps reappearing in itself. And when you build a fundamental model of the cube octahedron, the only structure that has equal radius and equal edge length, right? What you get is an expression of 7 of these things it takes to make that hexagonal shape. So the number 7 to me is a very, very deeply paradoxical, interesting number. And it was what led me to find a natural number system on the electromagnetic spectrum, out of which is a full mathematics. You can do addition, subtraction, multiply, and that's where I found the primes. I found the primes on this wave line, and the primes just appear. They're not random. They are aperiodic. You can't tell, they're unpredictable, but they come out of a pattern. That is not randomness.
Yeah.
The universe is not random. The universe is unpredictable because the patterns are so complex.
Beautiful, beautifully put. Just a final observation from you. Anne-Marie Goncalves Desai has a beautiful quote from Claude Debussy, that music is the arithmetic of sound, as optics is the geometry of light.
Oh, yeah.
Music is the arithmetic of sound, as optics is the geometry of light. Now, what does your beautiful mind do with that, Joe?
Oh, absolutely beautiful. Yeah, that's wonderful. I said to her, come, let's play drums together.
But your last point, I think, is such a fundamentally important one, is that it's all emerging out of a very deep pattern. And that this pattern may appear on the surface to be chaotic, but it's only because you're not able to discern deeply enough the substrate fractal patterning out of which the seeming chaos has emerged. And so I want to thank you, and in just the moment that we have left, to say just one more word about this drumming, because I think sound is such an important. Why is drumming important to you?
I think first of all, I'm just a musician, so I'm a drummer, a kit drummer from way back, and I just wanted to keep in that. When I got into hand drums, the difference in the vibratory sense of what was happening to me was just profound. And so I switched off of kit drums and became a hand drummer with drums that gave me a lot of resonance. I started to do this in corporate training. I was a corporate trainer and did that kind of work. And I discovered that by introducing drumming to these executives, it just basically kind of reduced a lot of the angst and so on of being in a group. So drumming for me has been about community. I'm pretty asocial, actually, in terms of I'm hermetic and I like to be alone. I like people, I love people, but I'm not very sociable. And what drumming did for me is it opened up that whole aspect of community. And so locally, we do community drum circles. And the amazing thing is to watch from 3-year-olds to 93-year-olds sit in this field of energy. And we sit, and without any words, without any facilitation, we play. And what comes out of that is just such an enormous, you see the faces light up and people leave. And what I've discovered is that people heal themselves. I started getting people coming to me and saying, you know, I was with my doctor last week and I had this heart arrhythmia and he thought I might have to do surgery. I came to your drum circle. We've done a couple of sessions. I went back to the doctor, said your arrhythmia is gone. So these are anecdotal stories that I just take, and that's not the only one. People have a way of finding within themselves something that comes out of that rhythm and getting past, I'm not a musician, I can't play, to actually having that whole brain, right, left, movement and engagement. It's accelerated learning for me was what drumming is. It engages the whole body and it basically draws you in, and it's a community thing. It's just something that's so easy to share. But the vibratory impact, again, is what drew me in. That the sense that all is vibration and that the drums were telling me something that I needed to learn.
Yeah, that as Nassim says, in the end, it's about spin. And if you're spinning, you're making a sound.
Absolutely.
Well, Joe, thank you so much. And everyone, you're welcome to join the after chat session. The link is in the chat, so you can and copy it. And Joe, you're welcome. And I'm mindful that tomorrow is Thursday, the 26th, and it's Thanksgiving in the United States. But we're going to continue anyway to have Humanity Rising at 5:00 p.m. Central European Time, because the rest of the world has a normal schedule outside and beyond the United States. And we're going to deepen the dialogue again. Having heard about the unity of everything, David Baum, Krishnamurti, and then today on the geometry and the patterning of the unity and the everything. And then tomorrow, we're going to delve into the subject of, so given all this, how do we reconnect with nature? If everything is unified, everything is spinning ultimately as one, how can humanity, who seems to have so dramatically lost its way, find its way back into the wholeness again? So that's the subject for tomorrow. And but Joe, I want to thank you very, very deeply for a fascinating and illuminating, and I would love to have you back actually just on the Enneagram. The Enneagram is a fascinating tool for self analysis and growth. So let's be in touch about a session on the Enneagram. It would be wonderful to have you back. So thank you, everyone. We'll see you in the chat group, and we'll see you tomorrow, same time, same station here on Humanity Rising. Bye-bye.
Bye-bye, Jim. Thank you.
Great session, Joe.
Thanks for